So we're considering a series of 4 vectors, and here we're asked to find the vector projection of D onto C. So let me start by just drawing out what D and C are quickly. So C is 3i minus 1j, so it's going to have quite a big positive x component and a small kind of y component going downwards. So that's C. And D is 2i plus 2j, so both are positive x and positive y component, which is D. So what we're looking for here is the projection of D onto C. So if we draw this, where they're both kind of stemming from the same point, what we're looking for is kind of this part in here. So this is the projection of D projected, that's a right angle in there, onto C. So we're looking for this bit. So I'm going to write this as PROJ for projection, little c because that's the one it's being projected onto, and then D. So the general equation for this calculation is that projection, and usually we use U and V. So the projection of V onto U, which would be this order here, is equal to vector V dot vector U divided by, the magnitude of U. And then all of this gets multiplied by U on the magnitude of U again. So if we swap it over into what we're using, so ours is going to be the projection of D onto C, like that, and we'll just replace the notation here. And we get that. So what we need to go through and find is essentially the dot product here. We need the magnitude of C and then the actual C vector we've been given in the question. So let's start by finding the dot product. So D dot C. So we know for the dot product, all we're doing is multiplying together the corresponding components and then adding them together. So here we're going to get 3 times 2 for the i's, and then this is -1 times 2 for the j's. So this is 6 minus 2, or 4 for the dot product. Alright, so the next thing I need is the magnitude of this C vector. So we know that the magnitude we can get by applying Pythagoras' theorem. So the first component is 3, so that gets squared, and then the second component is -1, which gets squared. So now we have the square root of 3 squared is 9, plus 1 squared is 1, so overall this becomes the square root of 10. So now what we should be able to do is go back and substitute into our expression here. So D dot C, which is the top line, that went to 4, and then the bottom line here is the square root of 10, so that's what's inside the bracket. We've then got our vector C that we need to pull out, which we were given in the question, so 3i minus 1j. And that gets divided by the magnitude again, which is square root 10. So we should be able to put these constants together. So 4 on the top line, and then we have square root 10 times square root 10. The square roots essentially cancel out with each other, and you're just left with 10 on the bottom line. And we've got the minus 1j. And then if I wanted to, I could write this as like 0.4. And then I'm going to multiply that in. So 0.4 times 3 gives me 1.2i, and then 0.4 times -1 gives me -0.4j. So this is my vector projection. And if we go back and resolve this against the picture I drew at the beginning, we can see we have a positive x component and a negative y component. So if we go back and look at the picture here, you can see that this projected vector does have a positive x and it does have a negative y. So it looks all consistent there. So that's all there is for this video. See you in another one.